Let's start off the first problem of chapter 2 by reading the exercise. In this exercise, we let the number of claims n have a distribution that looks like this. Now, before we begin, let's just try to take a look at what this means. So the number of claims, we say, can be either 0 or 1 or 2. And often we can probably, if we're looking at an insurance company, then we mean for any customer that we have, then that customer can either, for a given year, have 0 accidents, 1 accident, or 2 accidents. And that person has 0 accidents with probability 0.8, has 1 accident with probability 0.15, and 2 accidents with probability 0.05. So that's what we mean when we let n be distributed as such. We're asked to find the mean, the variance, and certain things down here. So let us write up the definitions so that we know what these different things are. And note that n is discrete, so we're trying to calculate stuff in the discrete case here. So n is discrete. So the definitions give us the following: that the mean of n is given by the sum from 1 to infinity of the value n multiplied by the point probability Pn, which is the same as saying the probability of n being little n. So that's the mean. And the definition of variance, and this is something that holds both for discrete and continuous variables alike, is given by the second moment of n minus the square of the first moment of n. And we recall that if we want to find the mean value of some function g of a discrete variable n, well, then what we do is for each of the values g of n that your discrete variable can attain, and see, in this sum we let n be 0 to infinity, because g of n might not cancel out in the same case, because up here, when n is equal to 0, the first term just cancels out because this term is just equal to 0. But here, g of n, when n is equal to 0, then g of 0 might be 2 or something like that. So that doesn't just cancel out. So we write g of n for n going from 0 to infinity, and then we take each of the outcomes and multiply by the probability that we gain that outcome. So yeah, this is how we write up the moments of n. And we are also asked to find the probability that n is equal to something given that n belongs to some other set. So let's just recall conditional probability. The probability of an event A given the event B is equal to the probability of their joint event divided by the probability of the event we're conditioning on. And last but not least, we will also be asked to find the conditional expectations. Now, the conditional expectations, this is kind of a new concept for you guys. So in this exercise, let's just start up by just calculating it and by writing up the definition. And then we can go deeper into the interpretation a bit later. So the mean of n, given that n belongs to some set. Well, you can actually find the expression for this in the bottom of page 18. There you have the continuous version, but the discrete version is actually exactly along the same lines. It's given by the mean of n multiplied by the indicator of n being an A, divided by the probability that n belongs in A. And what do I mean by the numerator up here? Well, by the numerator up here, the mean of n multiplied by an indicator of n, what we mean is for each value of n, when we try to find the mean value, so for each value of n when we calculate the mean value, we consider, does this value of n belong inside the set A? If it does, then this indicator has value 1. If it doesn't, then the term cancels out because the indicator has value 0. So the mean of n multiplied by an indicator of itself belonging to a set A is given as this expression that I'm writing up here. And I think that these are all the formulas that we will need to calculate stuff in this exercise. So try to find this in the book. You probably won't be able to find this part for yourself. So write that down in your notes or in your formula collection, and then we will continue in the next video with the calculations of the mean and the variance and so on.